So, armed with this new information that this black power monitor uses an external A to D converter, 18-bit A to D converter, let's look at the circuitry and find out where it is. Now, the plot does thicken a bit at this point. When I first looked at the red power monitor, I assumed that this chip here, this little 6-pin SOT23, was an op-amp, because you can see quite clearly that two of the pins are connected directly across the current sense resistor. So I assumed that was an op-amp. It was multiplying the voltage up, and then the analog to digital converter inside the microcontroller was measuring this magnified voltage. But no, that's not the case. This actually is, on the red and yellow units, the microchip MCP3421 18-bit A to D converter. So the red and yellow units also have an 18-bit A to D converter. The difference is that the black unit has two of them. There's one of them, 18-bit A to D converter, looking at the current, the voltage across the current sense resistor and therefore calculating current. And there's another one up here, and this is new to the black unit, that's measuring with great precision the voltage across the outer two connections on the USB. So all this fanfare about now using an 18-bit A to D converter, well, what it should say is now using an 18-bit A to D converter to measure USB voltage, but we've always been using an 18-bit A to D converter to measure current. Now, the D plus and D minus voltages on the two center pins here, you can actually see them routed through to the microcontroller. They are actually being read by the 12-bit A to D converter in the microcontroller, but of course they're not high precision measurements, so that's perfectly acceptable. And this is a really fascinating chip, this microchip MCP3421. It's a single channel low noise high accuracy delta sigma A to D converter with differential inputs and up to 18 bits of resolution in a small SOT23 6-pin package. And a few things jump out here. It's got a programmable gain amplifier. So it's actually got a built-in op-amp that you can set the gain to 1, 2, 4 or 8. So I'd imagine when measuring current it's set to the maximum 8. Now you're not going to be using the full range of the A to D converter, because even multiplying the voltage across that current sense resistor by 8, it's still going to be quite a small number. But you've got this incredible precision. So you can get measurements of current with 4 decimal places of accuracy. Now something else jumps out at you here. If you want 18 bits of A to D, the sample rate is only 3.75 per second. That's incredibly slow, but it doesn't really matter in this application because you're only updating the screen about 3 times a second. The maximum speed is 240 samples per second, but then you're only going to get 12 bits of A to D resolution. So that clears up the mystery. The microcontroller on both units is the same. It has a 12-bit A to D. The current sense measurement has always been done on both units by this 18-bit A to D, but the black unit has an 18-bit A to D also for measuring voltage, and that's how they're getting 4 decimal places of accuracy on voltage. And there's something else. The red and yellow units can measure voltage on the USB up to 13 volts, and that's handy for the Qualcomm Quick Charge 2.0, but this unit can measure USB voltage up to 24 volts. Now that might sound a bit unnecessary, but the USB 3.1 spec can actually run USB voltage up to 20 volts. So this thing is USB 3.1 ready. So here it is on Wikipedia. You just look up USB power delivery, and the profiles here include up to 20 volts, up to 5 amps. That's 100 watts of power through USB, and this unit is ready for all that. So I'm really liking the technology in this black YZXstudio power monitor, but I still don't like the black plastic case. These power monitors are quite expensive, but they're very high tech. They're very precise. I mean, they're perfect for doing proper measurements on power banks and also USB solar panels and in fact anything USB. So why make this one look like a charger adapter, or even worse, a USB dinky? Do you remember the USB dinky? I'm going to power it up just to remind you. There, horrible, isn't it? And the black power monitor, I mean, really, does it look so different? So, thanks very much to Frankie Tong for sending me the latest black USB power monitor. Haha, fooled ya. But I mean, come on guys, let's go back to these. These were so much nicer looking. Cheerio.